Happy Monday, everybody. Welcome back to another Planetarium live stream. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And thanks for joining us on this very chilly Monday. Hope you're all staying warm out there. It has been a cold weekend, both weather-wise and spirit-wise. All you Kansas City Chiefs fans out there, I just want to say it was a great season. And only up to go for next season. So let's just go and move on and just pretend like last night never happened. Welcome back to another live stream, everyone. Thanks for tuning in, and hope you all are doing well. For our returning watchers, welcome back. I know we've got some of you longtime watchers joining us in the comments. And for all of our new watchers, welcome. Hope you enjoy this stream today. We're going to take a deep dive into an astronomy topic, as we've been doing every week for the past year. And tonight's topic should be pretty fun. It's going to be a little bit about Earth, but a lot about exoplanets. So we're going to talk about planets and around distant stars. As a reminder, this is a live stream, so if you are in the comments section, let us know. Say hi. Let us know where you're watching from. We love seeing everybody who's watching. Already having some people chiming in. Lisa says hello. Tammy, one of our longtime watchers. Thanks for welcome back, Tammy, for watching us again. Welcome back. Tammy says hello from Iowa. We all here really enjoy these and learn a lot. Thank you. Well, thank you, Tammy, for being one of our top fans and continued supporters. It's always so much fun seeing your name pop up every Monday, so thanks for continuing to watch. Angie says Union Station has a planetarium. Surprise, surprise, Angie. It sure does. And that's a great segue, because the planetarium at Union Station, the Arvin Gottlieb Planetarium, as it's officially called, is open to the public. So while we've been live streaming here from my little pocket dimension for the past almost 12 months. We're on month 11 now. We are also open to the public, have been for quite some time. And if you do want to support Union Station and the planetarium, then coming to see one of our shows is obviously a great way to do that. You can buy tickets online in advance. We are open Thursday through Sunday right now, and we're going to be returning to being open on Wednesdays here next month. So stay tuned for schedules there. Yeah, please come visit us. You know, we love seeing everybody at the planetarium. Of course, that's our bread and butter, where we do most of our content. Our live star tours, of course, our most popular show, but we have other shows, documentary features about dinosaurs, Mars. We have shows for kids like Big Bird's Adventure and Magic Treehouse, based on the kids book series. A lot of great options for all ages. But don't worry, your support watching us for these live streams is also invaluable and so important. Thank you so much for your support in this way. It's great just keeping us relevant and keeping us in y'all's minds while we are dealing with these unprecedented times, as if you wanted to hear that word said again. So thank you. And Angie, that is true. We do have a planetarium, and I'm glad you think that's awesome. Come visit us sometime if you would. All right, Eric is chiming in saying Granny says hi from Lenexa. Hi, Granny. Thanks for watching. Chris, another one of our longtime watchers, says, hi, Patrick. Hey, everyone, make sure you subscribe on YouTube to the planetarium. Wow, Chris, man, you are amazing. And that is an excellent, excellent segue as well, because for all of our first-time watchers or new watchers, we do post all of our past live streams on our YouTube channel. Just go to YouTube and search for Arvin Gottlieb Planetarium. You can find us there in all of our past live streams. We've covered so many crazy topics. In fact, this is live stream number 60. Can you believe that? We've done 60 of these live streams for a total of 48 hours. That's 2 whole days solid of streaming. That blows my mind, and I'm so thankful and grateful to everyone who has supported us. And so go over to YouTube and give us a like and subscribe there, because you can watch all of our past streams where we've covered topics like the moons of our solar system, TV show and movie astronomy. We've made a comet in my living room, which was super fun, using materials you can buy at a grocery store. So a lot of awesome streams to check out there. Just search for Arvin Gottlieb Planetarium, and subscribing to us helps a lot, because if we hit 100 subscribers, then we will finally be able to be official, essentially, and we will get to basically have a fancy website name. Instead of youtube.com/blah blah 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 blah, it'll be /planetarium or something cool like that. So we're at 75 subscribers. Oh, we're almost at 100. Anyway, if you could subscribe, that would be amazing. So thanks for that shout out, Chris. Pig says, greetings, Earthling from KC. Greetings to you as well. And that's assuming that both of us are Earthlings. Kathleen says, hi, Patrick. I'm watching from Maryville, Missouri. Well, thanks for tuning in, Kathleen. Glad you're here with us. Stephanie says, definitely a highlight on Mondays. That is so awesome to hear, and it's a highlight for me, too, especially seeing you, Stephanie, and everybody else in the comment section. Joy is given a joyful emoji, so thanks for that. Mary says, hey, REH4, tuning in from Liberty. We can't wait to visit the planetarium, and we can't wait to have you, Ari, as well. So please come visit us as soon as you feel comfortable. Of course, we are following all the safe protocols for this pandemic, requiring masks inside Union Station, of course, and keeping socially distanced during shows. So as soon as you're comfortable, we'd love to see you at the planetarium. In the meantime, though, thanks for tuning in. And if you have any questions, don't forget to put them in the comments, because I love seeing your questions and I'd be happy to answer them. And Jennifer as well saying, so excited to see the show next week. All right. Ooh, are you coming to see a planetarium show? Hopefully that would be, hopefully you'll enjoy that. Awesome. And we also are doing laser shows right now, offered on Thursdays and Fridays at 4 o'clock, a matinee laser show. Every week is a different showing, which is pretty exciting. This week coming up is Beyonce, so I know all you bees out there definitely want to check that show out. It's definitely a fun one of my favorites. And stay tuned, announcements are coming soon about evening laser shows. Yes, we're going to be bringing back our nighttime laser concerts in the near future, so stay tuned. Those are coming very soon. Trevor says, it's so cold. Indeed it is. And Jordan says, hey, Patrick. And I say, hey, Jordan, thanks for watching. Glad you're here with us today. All right, so a lot of comments. Keep them coming, folks. We'll put a marker, and any comments that come from this point on, I'll be sure to check back in a little bit later. While we're still letting people tune in, we're going to check out a couple space updates. I like to start my streams with some news updates, just stuff, happenings in space and astronomy over the past week. And I've just got two big updates for this week. And if there are any big updates that I miss that you find interesting, post those in the comments too, because sometimes there are news stories that I miss, and it's kind of fun to explore that together. So if there's anything interesting you want to check out or you want me to mention in the comments about space news, then post that in there. But the biggest exciting thing was last Tuesday, the day after our last live stream. And let's get this set up here. Ooh. All right, let's full screen this. So we've been kind of following this story, tracking this story. The SpaceX group has been testing their large rocket, the Starship rocket, which will be much bigger than their Falcon 9, and eventually, hopefully, take take probes and people to Mars in the future. And SN9 was their 9th test of this rocket, and it happened last Tuesday. And this rocket was a success overall. The rocket did launch. We'll just fast forward to, you can see SN10, the next test, is actually right there on the launch pad next to it. And all right, we can see the liftoff of the rocket here. And this is a gigantic rocket, 10 meters wide, I believe. So just imagine this gigantic tin can flying up into space. And this did a low altitude hover test where it flew up to, I think, about 16,000 feet. And it flew there briefly, kind of hovering, testing out the capabilities of the rocket and its aerodynamics. Then it came back down to Earth, and it actually used its body to aerodynamically slow itself down using drag. And then at the very end, it tried to right itself back upright to have a soft landing. Because ideally, this rocket, the Starship, will be able to be reusable, just like the Falcon 9, SpaceX's other rocket platform. Unfortunately, though, at the end of this test, they had issues with all their rockets firing properly. And as the rocket came back down to Earth, it experienced what SpaceX likes to call a RUD, a rapid unplanned disassembly. And yeah, it blew up on the launch pad. But that's okay. You know, this is not a failure. Again, reusing the rocket is just sort of a bonus. The rocket itself functioned as expected, and they're learning a lot about the rockets and landing, even when the rockets explode. And I also wanted to point out that the rocket exploding is not that huge of a deal. After all, SpaceX has had a lot of experience with this, and their Falcon 9, which now is the most reusable rocket ever. In fact, there was a Falcon 9 launch just the other day on January 20th. That was the 8th launch of a Falcon 9 rocket, which means they've reused that rocket 8 times, which is incredible and way cheaper to reuse rockets than to build new ones every time. But it took a long time for SpaceX to get there, and just to give you an idea of that, here's a kind of a funny montage that SpaceX put together that they call How Not to Land an Orbital Rocket Booster. And they had tons and tons of failed landing attempts. You know, they tried to do a soft landing in the water a couple times, but you know, every time it would break up. They've tried to do, well, sometimes the rocket explodes in midair. They have you know, tried to do landings on barges, and well, sometimes they miss the barge a little bit and it explodes. Sometimes they get really close, but the rocket tips over. So at any rate, they have had dozens of failed attempts. The rocket sometimes getting bumped around from choppy waters on the ocean. But eventually, their Falcon 9 rocket did successfully land after a couple years of tests. And now today, again, we reuse the Falcon 9 rocket all the time. Some rockets being reused up to 8 times. So we are getting there. SpaceX is at least. So that SN9 test, although it exploded, is not a failure, just another step on the path towards getting that rocket reusable. So another news story I wanted to bring up, and this is slightly related to politics, but of course we want to keep things relatively politics free. But I did want to point out that we can't deny that there is a new administration in the White House right now, and they have recently, well, the press secretary for President Biden was recently asked about the Artemis program, which was NASA's program that is targeting bringing astronauts back to the moon in about 3 years. You know, what often happens between presidential changes, regardless of party, is that the plans for NASA change, just like the plans for all of the other branches of government, because there are new budgets and new directives and missions and things like that. So we always expect this regardless of who's going to be president. But the press secretary did vaguely state that President Biden is hoping to continue the Artemis program. Now, there may be smaller adjustments and cuts made to that, but overall, having their administration endorse this program and support it continuing is a good sign, because that way scientists don't have to go back to the drawing board and redo all of their rocket plans, as has often happened in the past. Again, to many different types of administrations from all ends of the political spectrum. All right, so those are the two little news articles I wanted to bring up. A couple other comments and shout-outs. We have Chris enjoying the RUD landing, the rapid unplanned disassembly. Those are always interesting to see. Who doesn't love a good explosion? Shandy's watching from Oakley. Thanks for tuning in, Shandy. James and Donna are saying that these are so fun. Well, you guys are so fun for watching, so thanks for tuning in. If you have any questions, feel free to put them in the comments. Jordan says, by the way, the James Webb Space Telescope is still scheduled for October 31st, 2021. And that's a great segue, Jordan. And I appreciate your optimism. I sure hope the James Webb Space Telescope launches as it is scheduled for this year. There have been a few delays for that telescope. By the way, if you want to learn more about space telescopes, I did a whole space telescope live stream quite a while ago. That I am going to attempt to find while talking and vamping. Yes, it was on October 5th of last year, and also did a stream on satellites 2 weeks ago on January 25th. So if you want to learn more about those, check out our YouTube channel where all of our past live streams are posted. But I am going to talk about the James Webb Space Telescope during this stream today, Jordan, and this is a great segue because we are talking about exoplanets today. Now, I teased on our Facebook page that this stream would be about Earth as well as exoplanets, and that is true, but I wanted to talk a little bit about Earth. You know, we have covered so many aspects of the solar system, all of the other 8 planets. We've talked about the sun and stellar evolution. We've talked about moons and asteroids and comets and so many different aspects of the solar system, but there's one planet that we haven't visited, and that is Earth. Now, I often joke, mostly jokingly, that Earth is my least favorite planet. Of course, I do love Earth since we live on Earth and it's a beautiful place, but there are so many other cool places in our solar system that I'd like to visit someday. So it may not be my official least favorite planet, but it is an interesting planet. Obviously, there are many science areas of science that study the Earth. There is, of course, geology, which provides us insights into the origins of the breathtaking and varied landscapes all over the planet. There is meteorology that helps us to understand more about our oceans and atmosphere and weather patterns, which reveals truths about our changing climate. There's the study of biology, which of course reveals the relationships and secrets behind countless species of life found in every corner of the globe. Life is teeming in every place you look on Earth, and some places you may not even expect, deep in the dark depths of the oceans and in some of the extreme regions of our Earth, such as polar climates and deserts. And then there are some of the harder sciences like physics and chemistry, which dive into the fundamental mechanics of how our universe works. And it also helps humans to construct marvels of engineering and cure global diseases. So all these different aspects of science are looking down on Earth and studying the Earth. But this is an astronomy live stream, and the planetarium focuses on astronomy. So where does astronomy factor into the study of Earth? Now, after all, a lot of astronomers often turn their attention away from the Earth, looking up to the stars, their heads in the proverbial clouds, as they say. But astronomy is connected to the Earth in a few ways. Today's live stream, we are going to focus on one of these connections, which is the study of exoplanets. And before we start talking about exoplanets, I want to talk a little bit more about Earth and what makes the Earth special. We love the Earth, obviously. It's our home. It's where we live. By the way, I did notice Eric commenting a bunch of Phoebes. Yeah, I definitely did purposefully put that picture of a flock of galahs in there. By the way, just a sidebar, Phoebe will not be joining us for our live stream today. She is actually hanging out with some other bird friends right now. She is being boarded because I am taking a little vacation next week. So I'm going to take some time off. Phoebe's going to hang out with some bird buddies. And we'll be back next Monday, don't worry. But anyway, Phoebe unfortunately will not be joining us for our stream today. Just wanted to shout that out. So let's talk again about the Earth a little bit. Now, what does make Earth special? What is actually special about the Earth? We've talked about many of the other planets in our solar system, amazing planets with a lot of different features and interesting atmospheric compositions and surface features and origins. But Earth is special, and there are specific reasons for that. Now, one reason is that the Earth has a nitrogen and oxygen-rich atmosphere. This is a really cool graphic that I love bringing up. A credit to compound interest here, compound chemistry. And this is really, really a slick graphic showing all the planets in our solar system, as well as a couple other bodies, Titan and Pluto specifically. And their atmospheric compositions. Now, interesting here, look at Earth. The primary composition of Earth's atmosphere is nitrogen, which is a fact not a lot of people know. In fact, oxygen only takes up 21% of our total atmosphere. But of course, oxygen is very important to us. We often breathe oxygen, which is fairly helpful to us staying alive. And as far as science is concerned, especially biology, life as we know it, life as we consider it today, as we observe here on the Earth, requires oxygen. Now, there are some scientists who think life could exist out there in the universe that could require other compounds like ammonia or methane, for example, but there are no examples that we've found, which could be important because, for example, Titan has a methane-rich atmosphere. In fact, there are oceans of liquid methane on the surface of Titan. It's the only other body in our solar system that has liquid bodies of water, bodies of liquid just stuff on its surface, not water here, as I said, methane. So again, there are scientists who theorize that life could exist in a form that doesn't require oxygen, that requires some other compound similar to oxygen, but we don't have an example of that yet. Now, the other main reason, of course, that Earth is special is that Earth is a water planet. The blue marble, as we often call it, this great photo taken from one of the Apollo missions, I believe, yeah, it's covered in water. 70% of the Earth's surface is covered in water, and we rely on that water in so many different ways. Of course, water is a critical ingredient for life as far as we are concerned. Now, water does exist in other places in space, even here in our solar system backyard. It exists in the atmospheres of other planets as well as other organic compounds. If you want to learn more about that, I would recommend checking out the Venus live stream we did on October 12th. last year. And we also found water hidden below the surface of some icy moons of Jupiter and Saturn. And prospective live streams for those are on June 29th and July 6th. So check those out if you want to learn more about that. Again, on our YouTube channel. Be sure to like and subscribe. But Earth is the only planet we know of that has surface water in liquid form. So water on the surface that exists as a liquid, the oceans. Now, scientists assume that so water on Earth is a critical ingredient for life. Every single type of life that we know today essentially requires water. So when we look up into space and we look for other planets that could support life, exoplanets or Earth-like worlds, then we are also looking for water. Now, scientists do assume that if life does exist out there somewhere, it probably requires water. But there's an old joke that goes something like this. There is an old man on a, well, doesn't have to be an old man, but there's a man on a dark night who is searching around for something in the light of a street lamp. And a passerby walks by and asks the man what he's looking for. The man says he's looking for his missing car keys. And the passerby asks, why is the man looking for his car keys beneath a street lamp? And the man says, because the light's better there. So how this pertains to the search for life is that life on other planets may look nothing like life on Earth. It may not require water or oxygen at all. It may follow mechanics in biology that we do not understand right now. But because we know that life on Earth requires water, that's just our starting point. That's just what we're going to start with, and because we don't know of any other life that uses anything else, we don't have anything to go on, so we're just starting with what we know, essentially. And this is also a possible reason why we haven't found aliens, or why aliens haven't found us, because that life is unrecognizable. If you want to learn more about the search for life specifically, I would recommend checking out our Space Mysteries live stream, which was our Halloween live stream last year on October 26th, which was a lot of fun. I did that in black and white, wearing a tuxedo. And if you are a fan of the Twilight Zone, be sure to check out that stream. That was a fun one. So anyway, water and oxygen are the best leads we have looking for life on distant worlds. So that's one of the big things we look for when we look for exoplanets, especially exoplanets in the habitable zone. Looks like we got a comment from Mandy saying, by the way, love the flag in your background. It's a wonderful double entendre, both of LGBTQ plus representation and the tie-in that we're all made of space stuff. I appreciate that, Mandy, and I appreciate that you appreciate this flag. It's pretty cool. I put this together myself. Yeah, space stuff is cool, and all the different people on Earth are as cool, or just as cool, if not even cooler. And there's a lot of cool different things in space, just like there are a lot of cool different people on Earth. And we do have a link to this backdrop if you want to download it. I think we can post that in the comment section. So thanks for that shout out, Mandy. Glad you enjoyed that. So now let's talk a little bit more about water. Now, water on Earth exists as a liquid, right? But water has a fairly narrow range of pressure and temperature that allows it to maintain its liquid form. So there's a limited distance a planet can be to support liquid water, and therefore be a candidate, as we currently consider, for supporting life. And we have a name for that zone. We call it the habitable zone, or the Goldilocks zone, because just like Goldilocks was looking for that bowl of porridge that was just right, not too hot, not too cold. When we look for exoplanets, planets around distant stars, and we're looking for ones that could support life, we are looking for planets that are in this Goldilocks zone. Just close enough, but not too far, that they potentially could support liquid water, and therefore could support life. If they're too close to their parent star, then water evaporates from the heat of that star. If they're too far away, the water freezes and becomes unable to sustain most life, again, as we know it. Now, this zone changes its range depending on the temperature of the system's main stars. You can see in this chart, and we can see our solar system's habitable zone right here, corresponding with our yellow sun. Now, we can see that Mars here is on the right-hand side, and curiously, Mars appears to be in our solar system's habitable zone, technically. And technically, it is. It is in a region that could support liquid water, although it is very much on the edge. Now, the search for water on Mars is one of the main reasons we visit Mars with our probes. And we do know now, thanks to the Curiosity rover that arrived on Mars in 2012, that Mars was once covered in oceans of liquid water in its distant past. If you want to learn more about Mars, check out the August 10th live stream I did last year, all about Mars. And stay tuned as well, because in 10 short days, another Mars rover is landing on Mars. The Perseverance rover, Curiosity's cousin, a similar rover to Curiosity that was just launched last summer and is arriving on February 18th. So stay tuned. We're going to have a special event at the planetarium, actually, with special activities, and we will be monitoring the live stream of that landing at our IMAX theater, which should be super fun to check out. So stay tuned for details on that. And I'm also planning on doing a special live stream that evening to kind of recap the landing and check out some of the, hopefully, the first images from this lander. So again, that will be in 10 days, which will be next Thursday, February 18th. That'll be pretty exciting. So, exoplanets. Now, this is a growing field of study in astronomy, and let's define it a little bit. An exoplanet essentially is a planet that's confirmed to exist around a star that is other than our sun. So a planet somewhere out in space, not a part of our solar system. Now, thanks to many recent missions, especially missions like the Kepler Space Telescope, we know that there are more planets in our galaxy than there are stars. So again, by doing the math, we know that there are likely more than 500 billion planets in our galaxy alone, the estimation of how many stars there are. So we think that most stars in our solar system, our galaxy likely have planets around them, and many of them multiple planets like our solar system. So we know that there are planets out there, but how do we find those planets? There are a couple different methods of detecting an exoplanet. There's direct imaging, which is basically looking through a telescope directly at an exoplanet. And this is pretty difficult. You can do direct imaging by blocking out the light from the star. Otherwise, that star is going to be so bright it's going to drown out anything that we might see near it. So what they do is they use a technique called a coronagraph, which basically just blocks the light from the star. And then you can see here actual video footage of planets orbiting a distant star, which is pretty incredible. Now, this is able to be accomplished using telescopes like the Hubble Space Telescope, but very few exoplanets have actually been found in this way, and most of these exoplanets are young, large gas giants orbiting very far away from their stars. They're so distant and large that they are gas planets, so not terrestrial planets, worlds with surfaces essentially, as far as we know, and they're very, very distant, so likely incredibly cold. So definitely not candidates for supporting life, but still very interesting. But most of the exoplanets we find are via indirect methods, and these are methods where we aren't really seeing them directly, but we are detecting them using a couple pretty cool techniques. So one technique is the transit method, which we can see here. Basically, when a planet passes in front of a star, the star's brightness will dip a little bit, and this is exaggerated, of course, for the sake of this chart, but by plotting the star's brightness and observing it change at regular intervals, we can assume and infer that there could be a planet blocking the light from that star, and that planet could be orbiting. And depending on how dim the star is getting, and depending on the speed at which this transit happens, we can make some mathematical inferences about the size of that planet and its gravity and things like that. That's one method. There is also spectral analysis. And this is basically measuring Doppler shift of a star's spectra as a planet pulls on the star with its gravity. So planets can be, even smaller planets, their mass can be great enough that we can actually detect their gravity pulling stars, pulling their parent stars. And basically by measuring the shifting light coming from these stars, we can measure what direction the star is moving in. And this is very, very small measurements, but thanks to computers, we can really calculate these tiny numbers, but we can actually detect exoplanets in that way. We have a name for this, actually. Scientists have nicknamed it the wobble method, which is kind of funny. Basically observing stars wobble around thanks to planets pulling on them. There's another technique called gravitational microlensing, which is a mouthful, but this is a very cool technique, and it's sort of opposite to the transit method. The transit method observes a star's brightness getting lower as an exoplanet passes in front of it, but the gravitational microlensing actually sees the star's brightness go up thanks to the gravitational field of an exoplanet. So when an exoplanet passes in front of a star, if it's large enough, we can actually see its gravity lensing the light from that star, from the star behind it. And what basically this results in is more of the light from that star actually reaching the Earth, and that star's brightness going up. Now, this requires a very specific configuration of the distance of that star, its planet, and the Earth. So this is a bit rare, but it is a technique used to find exoplanets. Now, all these different methods have problems by themselves, of course, but often scientists will combine them. And when we combine all these methods and use them together, we can learn, we can be more sure about exoplanets. We can confirm them, for example. There are a lot of exoplanet candidates, but this way we can actually confirm and say this is for sure an exoplanet. And we can also learn more vital information about that planetary system, such as information about their atmosphere. For example, we can use spectral analysis to actually infer what elements are found in the atmospheres of distant planets. Essentially, as the exoplanet passes in front of its star, it blocks certain wavelengths of light from that star, and as that light is absorbed in the atmosphere of that exoplanet, and here on Earth, we can actually use what we know about spectral analysis to infer what element that might be in the atmosphere. So we can actually measure the atmosphere of exoplanets this way, which is really, really crazy. Now let's talk a little bit about some cool exoplanets, and to do that we are going to use one of my favorite tools, which actually just got a big upgrade, and that is the NASA's EYES. Now this used to be a program that you had to download on your computer, but now you can actually get it in your browser, so it probably works on mobile devices too. But let's pull it up here. So this is NASA's EYES, and this is they have a whole module all about exoplanets. And this is a really cool tool, and it's kind of like a virtual planetarium. We've been using other software during our streams that is pretty similar to this, and this is just totally free on the internet now, which is really crazy. Now, as you can see, this has a lot of satellites, which we're going to talk about some of these satellites, but it also has our current known surveys of exoplanets. So all these colorful dots you see here are exoplanets we have confirmed. So if we zoom out here, we'll actually be able to see all these exoplanets and where they are in our galaxy. So here is the Milky Way galaxy, and many of the total sum of all the exoplanets that we have discovered from a number of different missions. There are a couple of cool exoplanets which we can search for here. For example, we can go to Kepler 186f. It is not available in this database. I was searching for it on Space Engine, my other software, earlier, so I guess it's not in there. There is one that I know is in there, though. Kepler, oh, maybe I didn't do 6. Oh, no, it is in there. Okay, great. I just didn't type the hyphen. All the Spider-Man fans out there will know how important those hyphens are. So this is cool. This is Kepler 186f, which is the first rocky planet found to be within the habitable zone of its star. So we can zoom out here, actually, and we can see this entire star system, Kepler 186. And if we zoom in again, this is a really, really powerful tool because we can also click on the planet, and it'll actually give us, we can click this plus here, and it'll give us an artistic concept of what this planet might look like. This is a super Earth, which is a terrestrial world that's quite a bit larger than Earth, but still smaller than Neptune. So it's kind of a medium-sized planet, a type of planet that we really don't have in our solar system. Ooh, sorry if I pressed the wrong button here again. All right, so again, there's Kepler 186f, and again, this is a super Earth that orbits a star at a pretty close distance. It's about half the distance from the Earth to our sun, but it gives us a lot of information. In fact, we can see how long it would take to travel here from the Earth. So if we were going at the speed of a car, it would take 6 billion years. At the speed of a jet, only 627 million years. The Voyager space probe, which is currently exiting our planet, could arrive there in 10 million years, although I don't think it's pointed in that direction. And even at light speed, it would take 561 years to get there. So it's 561 light years away, which is very far away. And it'll tell us it's observed by the Kepler Space Telescope. So again, if you missed this earlier, this is a cool 3D view of this exoplanet and its system. We can also visit, let's check out, what's the other one I want to see? Yeah, Kepler 16b, which is a bit of a Star Wars planet. We've actually checked this one out before during our Hollywood live stream. But this planet is likely a gas giant planet, so a little bit different than Tatooine. But it is similar to Tatooine from Star Wars because it has 2 suns. So this is a rare planet that is actually orbiting 2 stars simultaneously, which are orbiting each other. Kind of a crazy system, and again, gravity is just keeping this system together, and It's pretty amazing that that can actually work that way, but this planet has 2 suns, so if it did have a solid surface, then there could be an alien like Luke Skywalker watching the double sunset with John Williams playing in the background. There is Kepler 22b, which is one of the most famous exoplanets. This is in the habitable zone of its star as well, and it is possibly a water world. So scientists think that this is one of the top candidates to be in just the right spot, that liquid water is likely to exist on its surface, assuming that there aren't other factors in there like greenhouse effects and stuff like that. And this is another super Earth, so quite a bit larger than the Earth, and you can see the size comparison there. Its mass is 36 Earths, but it has about 2 times the radius, so about twice as wide as the Earth. Or almost about 3 times as wide as the Earth, I suppose. And another system I wanted to visit is the TRAPPIST system. So let's go over to TRAPPIST-1. And this is a really amazing system. This was the first, or the largest batch of Earth-sized planets ever discovered in a single system. And this is an amazing system of 7 Earth-like worlds. Now, of course, we don't know all the details about them, but we can make inferences based on the data we've discovered. Now, what are some of the missions that we have actually sent to discover exoplanets? Let's check some of them out, and we can use our software here. Okay, hopefully you saw that again. Keeps... all right. Sorry if you couldn't see that. Let's just visit the TRAPPIST system once again, just in case. So there is, again, the TRAPPIST system, which is 7 exoplanets, all within the habitable zone. So let us check out some of the missions. By the way, don't forget that if you're still watching, you can comment and ask any questions if you have them, or just want to say hi. It's always great to see your comments. Let us know where you're watching from as well. So in this website here, the NASA Eyes, we can actually visit some of the missions, and let's check out some of these missions. It's going to zoom us back to the sun here. One of these missions, actually, I want to visit the Kepler Space Telescope first. This was probably one of the most famous exoplanet discovery missions that we have ever sent. The Kepler Space Telescope was launched in 2009 and operated until 2018 on a couple different missions, because there were some thruster issues with it, but they actually repurposed its mission and made it work regardless of the technical issues it was having. Now you can see it's way behind Earth right now. It was an Earth trailing satellite, but try to zoom back in here. The Kepler Space Telescope, for most of its primary mission, pointed at just one region of the sky. And if we point the telescope at that region, you can see here that it's pretty crazy seeing this grid laid out, because it's pretty fun. We can zoom out away from the Kepler Space Telescope and see that it actually studied a... Oh, it's not going to... Let's reset here. So the Kepler Space Telescope, we can see its primary mission was searching for exoplanets in a region of space, and it kind of appears to us as a cone in 3D here. But again, when we zoom back in on Kepler, you can see that it was just studying a very small patch of our night sky. And this telescope discovered more than 2,600 exoplanets. There was also TESS, which stands for Transiting Exoplanet Survey Satellite, launched just 2 years ago in 2018. And so far, it's already found 107 confirmed exoplanets and has 2,500 candidates that they are still working on studying. So another exoplanet satellite. Of course, there's the Hubble Space Telescope, which is our old reliable space telescope until James Webb launches, hopefully this year. And this has done some direct imaging of some exoplanets, discovered a few interesting ones there. And the Spitzer Space Telescope, which is on here as well. This operated from 2003 to 2020, and it was the first telescope to chart an exoplanet's weather variations, which is pretty cool, and it also discovered the TRAPPIST system. So really fun website. I'd encourage you to check out. Just search for NASA Eyes, and they have an exploration of our solar system as well as exoplanets and some other interesting missions. A really, really cool website. Then, of course, there is the James Webb Space Telescope, which is scheduled for launch as Jordan pointed out earlier, on Halloween this year, and it is done construction, and they have done their final tests, I believe, or their final deployment. So they put all the solar sails and all the pieces out to test it one last time. They did that already, so it should be launching really soon, hopefully. And on this telescope, there will be a lot of instruments, but some of them will be specifically for looking for exoplanets. By the way, you can see it's quite a bit larger. Its primary mirror is quite a bit larger than the Hubble telescope primary mirror. So I mentioned coronagraphs, those blocking instruments that block out the light from stars so we can see the planets orbiting around them. And that will have advanced chronograph systems there that will allow direct imaging at even greater detail. So right now, scientists say that exoplanets are visible with our current technology anywhere from 10,000 to 1 million times fainter than their host star. But the James Webb Space Telescope will be able to see planets that are more like 10 million or even up to 100 million times fainter. So it'll be able to see exoplanets that were previously invisible. And we'll also have other technology that'll help us to observe exoplanets in new wavelengths, which will hopefully reveal other interesting things about them and maybe even more about their atmospheric composition. So James Webb, once it gets up there to space, will hopefully reveal even more about exoplanets. All right, Patience is commenting, says, hi y'all, and, or just, hi, excuse me, hi, yeah. Hi, yeah, I don't want to put y'alls in your mouth. Hi, yeah, from Colombia. Patience is one of our longtime watchers as well. Thanks for tuning in. I'm glad you're enjoying this stream. So I wanted to close out, and we are going to close out soon, so any last minute comments or questions, put those in now, please. But why are we looking for exoplanets? Why are scientists looking up into space and looking for distant worlds like Earth when there is so many amazing things to learn about back on Earth? Well, you know, a lot of scientists will say a lot of it is just the thrill of discovery, just looking for new places, new worlds, similar to why we explored the oceans back before we really knew that there was a whole wide world out there and we knew the Earth was round. So the thrill of discovery is a huge thing, as well as answering profound questions about our place in the universe. You know, are we alone is a big thing that is sort of more philosophical than scientific, but is still worth answering for a lot of people. But from a practical standpoint, learning more about the formation and compositions of other worlds it will help us to understand the Earth in a lot of important ways. You know, we know that whether or not there's life out there in the universe, life on Earth is precious and fragile. And learning about life in other places could help us to protect life on Earth and help it to grow and expand. And of course, finding another planet close by that may not have life but could support life someday could, in the distant future, help humanity to spread out amongst the stars. And that will further spur the spirit of exploration. And of course, it'll help humanity to endure and humanity's legacy to expand through the universe, which I think most of us can agree is a net positive. You know, we want humans to stick around, and right now Earth is our only shot, so it'd be great to not put all of our eggs in one basket, as it were. So the last little thing I wanted to bring up is that you can get involved in the search for exoplanets thanks to a little something called citizen science, and we can post this link for you in the comments section. But citizen science is how citizens, so normal people, civilians, can get involved in scientific endeavors. And the Exoplanet website that NASA actually has a whole page about citizen science. And there is a page where you can learn about how you can use your small telescope to help observe transiting exoplanets. There is also places you can go that will actually let you sift through scientific data and actually be a real part of the search for exoplanets, looking at differences in small numbers. You know, there's so much data that these telescopes have already gathered that we haven't even begun to look through. So getting citizens involved in this science is helping the search, and following a lot of these websites, you can help to learn, or to help scientists to learn even more about that. And of course, NASA has a page with other citizen science projects. So I'd encourage you to check that out. We'll post a link to that in the comments section below. So that is just about all I have for our live stream. And would you look at that? For the first time in quite a while, I am actually finishing before the hour mark. So yeah, we've had these live streams go quite a long time. for the past few months. So I'm proud of myself. I actually made it a goal of mine to keep this one under 45 minutes, and look at me, I did it. So thank you all so much for tuning in. I'm looking, and we've got just a couple more comments coming in at the last minute. Sandy says, hello from Strasburg, Missouri. Thanks, Sandy, so much for watching towards the end. I appreciate you tuning in for this whole stream. And Cindy says, Emirates probe Hope arrives at Mars tomorrow. How exciting. Very, very cool. So that is, that is something that I've talked about on past live streams. We did a satellite stream 2 weeks ago, as I said, and we've done a stream on deep space probes. Actually, that was all the way back in April 29th of last year, which is crazy. But yeah, the United Arab Emirates has a mission to Mars that's currently on its way, and that probe is called Hope, and it was launched in July of last year. And it looks like it should be arriving fairly soon. It's scheduled to reach Mars in February of 2021. So I hadn't seen any recent updates about that, but it looks like it is approaching Mars. So that'll be pretty cool. This probe will... Oh, here we go. Here's a news article we can put up there. So, yep, there's the Hope probe being launched there, and it's hoping to approach Mars, and it is going to orbit Mars and get some new science about Mars. And it's great that another country, the United Arab Emirates, is getting involved in Mars exploration. The more the merrier when it comes to science. So excited for them, and we will definitely try to post updates about that mission as new exciting things come out. So thank you so much, Cindy, for pointing that out. I appreciate that little news tidbit. Pig says, Encore. Well, I appreciate you wanting us to keep going, but this does bring us to the end of our content for today. But I do want to mention that if you do want to learn more about space, we have now 60 live streams that I have done in a total 48 hours of content, all on our YouTube channel. So if you haven't yet, go over to YouTube and search for Arvin, Gottlieb, Planetarium, and give us a subscription there, because every little subscription helps, and you can find all of our past live streams there. We've organized them by deep dives, as well as our Fan Friday Q&A streams we used to do, and our live seasonal star tours. So if you want to learn more, pigs, then check those out, because you can find all of our past streams there. And if you're watching on our Union Station Facebook page, also go over to the the Arvin Gottlieb Planetarium Facebook page and give us a like and subscribe there, because we post special space updates on that page that you won't get on the Union Station page. So check us out there. Stephanie says, way to go. I appreciate your vote of confidence, Stephanie. Thanks for sticking around to the end. Anne says, thanks for another great lecture. Well, thank you for watching. Patience says, I'm going to be forced to create a new file with all these links. Not happy about it. Well, I'm excited that you're going to have a lot of content to check out. You know, now that so many of us are stuck at home, we're probably running out of content on Netflix. So maybe doing a marathon watch of all of our past streams could be in order. So Patience, I hope you enjoy that. And I hope you enjoy the progression of hairstyles and beard styles over the past 11 months, because it's been quite a journey. And Eric, one last comment saying, great show, thanks. Thank you so much. And we are up to 78 subscribers already on our channel. That is so incredible. Thank you so much for subscribing. That's so great. Wow. And during this live stream, my goal is, before these live streams are over, to reach 100 subscribers. So we're almost there. It's a mostly meaningless goal, but it would still be a cool vote of confidence. So thanks again, everyone, for watching. We'll be back next week, next Monday at 6 p.m. And we are going to be diving into ancient Western astronomy as we are approaching the Ides of March. I believe our live stream will be on... nope, it is not. Ides of March will be next month. I do know it is February, but to celebrate the 15th, we're going to kind of fudge it a little bit, and we're going to do a ancient Western astronomy live stream on February 15th. So beware the Ides of February, as it were. But I just really wanted to use the 15th as an excuse to dive into Greek and Roman astronomy, because that is an area that is pretty pervasive in our study of astronomy, especially when it comes to mythology and constellations, but we haven't really talked about it during our live streams. I've done deep dives into a lot of other cultures' views of the sky. In fact, back in June of last year, I did 2 back-to-back live streams talking about different sky cultures from different places, such as Africa and Asia and the Americas, South America and Central America, and Native America as well, but we haven't really done just traditional Western astronomy. So we're going to do that on the 15th of February, the Ides of February. So tune in for that Monday at 6 p.m. Thank you so much for watching, everyone. I have been your Planetarium Specialist, Patrick Hess. Hope you have a wonderful weekend. I hope it's a lot warmer than tonight, and we will see you next week. Bye, everyone.